Hello, and welcome to this episode of EPRI Current. I'm your host, Bill Florence, and today we're talking about one of the components of clean energy, hydropower. We're lucky today to have two great guests to be able to discuss this important topic. And Francisco and Alan, why don't you please introduce yourself to our audience?
Thank you, Bill, for having us this afternoon. And so my name is Francisco Kuljevan, and I actually lead EPRI's Hydropower Generation Program. And my responsibilities around that is to lead the research activities for conventional and pump storage hydropower around asset management, operation, performance, and valuation optimization, technology development, and environmental challenges. So I'm happy to be here, and thank you for your time, Bill.
Great, thank you. Alan?
Hello, thank you for having me. My name is Alan Ettlinger. I'm the Senior Director of Research, Technology Development, and Innovation at the New York Power Authority, or NYPA, as we're often called. I'm responsible for all areas of research performed at NYPA, and that includes hydropower.
Great. Thank you so much. Thank you both for joining us today. So, Francisco, let's just jump right into this. And maybe before we get into some of the more substantive issues, can you provide us with a short, sort of high-level overview of EPRI's Hydropower Generation Program?
With respect to what kind of work we're doing right now, it is a very exciting time for hydropower. We are at a very, very important time through this energy transition. And there are really interesting things that are happening right now in this field around flexible operations, also better ways to do asset management so that we can extend the life of these assets that have been operating, some of them over 100 years. Also, we are in the areas of advanced sensors and data analytics. So we make sure that we are continuing to investigate not only the development of new sensors to begin from scratch, but also look at other technologies. EPRI has that ability to go across different technologies of electricity generation. And so we, as a hydropower program, we look at areas in which these sensors already developed could be beneficial within the hydro industry. So the last two are the topics that we'd like to look into it as related to the materials and repairs and also environmental challenges. So overall, a summary of the work that we're doing in the program.
Thank you. Alan, I don't know if you share Francisco's enthusiasm that he just talked about, but can you give us an overview of, not from your perspective, of NYPA's hydro assets, a little bit about the history and how are your assets being currently being used?
So the New York Power Authority is America's largest state power organization with 16 generating facilities and more than 1,400 circuit miles of transmission lines. Our first hydroelectric plant is our 800 megawatt facility known as the St. Lawrence Franklin Roosevelt Power Project, which began power production in 1958. It's a run-of-the-river plant that we share with Canada, has 22 turbines, 11 are ours and 11 are Canada's. In June, that's our first facility. In June 1956, a dramatic rock slide destroyed the Niagara region's largest privately owned hydroelectric plant. So NYPA stepped in and began construction in March of 1958 on the 2.6 million kilowatt Niagara Power Project, which at the time was the largest hydropower complex in the Western world. And not commonly known, our Niagara plant also has a pumped storage facility as part of the facility. In 1967, NYPA received a permit to build the Blenheim-Gilboa Pump Storage Project, which is 1,040 megawatts of pump storage in the Catskill Mountains. And finally, in the late 1970s, the Power Authority began a program to develop small hydroelectric facilities around the state. 5 plants with a combined capacity of 29,000 kilowatts are now in operation.
Alan, now the Niagara plant shares the river with a world famous sort of natural site there, doesn't it?
Yes, it does. What's another thing that's known is most people think that the water going over the falls is what generates our electricity. Actually, there is 4 conduits which run under the city of Buffalo and divert around the falls. And that's where the power comes from and into our Niagara plant. We have a number of treaties with Canada and controlled by the U.S. government to ensure that the water is always coming across the falls primarily for the tourists who get there to make sure there's not a dry river running through.
And we're referring to, of course, to Niagara Falls, which is, I think, maybe a subject for a whole nother podcast episode one day. Francisco, one of the main issues that sort of the hydropower industry is trying to address right now deals with long duration energy storage, including pumped storage hydropower. Can you explain that in a little more detail, please?
Yes, Bill. And actually, that's one of the pieces of the puzzles that the whole industry is trying to solve or improve, right? There are multiple technologies, and EPRI actually has its own long duration or bulk energy storage programs. And it'll probably be a good opportunity to maybe have another podcast on the different technologies that they're researching. The reason, one of the things about hydropower as a whole, right, it does contain that pump storage hydropower aspect, which is a reliable, let's say, over 100-year-old type technology that is used to store energy. And again, it's as simple as what they call, and I don't know if this term has been coined yet, but everyone talks about your green battery. It's basically just pumping water up the hill and then actually storing the water up until the time you actually need it. Now, we all know at this point, the reason why we need that long duration energy storage is the actually amount of penetration from variable renewable energy sources such as solar and wind. And so as we see that industry changing and our energy sources changing, we're going to see, and EPRI has done extensive research on the amount of long duration energy storage is going to be needed. And so hydropower and pump storage, hydropower specifically, is going to play a key role in that piece of the puzzle of the long duration energy storage. So, I mean, I'm super excited to work with Alan here. As he's mentioned, they have two pump storage hydro sites at Lewiston and also the Blinghal-Gilboa site. So we've worked together with NYPA on different studies related to the value that pump storage hydropower offers and basically provides to owner operators like the New York Power Authority. So I'm super excited about this, Bill, and we can talk about the whole podcast in terms of pump storage and long duration energy storage.
I think y'all are both angling to turn this episode into about an hour long, so we'll have to think about that. But so, Alan, how is NYPA sort of addressing or dealing with this issue of storage?
So, as Francisco mentioned, energy storage, long-term energy storage, is obviously an industry issue now with distributed energy sources such as wind and solar, and the need to basically store the energy when those environmental conditions are not there. So if the sun is not shining, if it's not windy, we still need the energy, and energy storage plays a role. Our hydroelectric plants attack this really from a separate angle. The pump storage facility as designed basically pumps water up from either a river or a lake up into the mountain and is stored there during the day when those distributed energy sources are available, and then or at night, and then would release the water and be able to generate electricity when needed. So our Niagara facility and our St. Lawrence facility are really base generation. In other words, just like a nuclear plant or another fossil plant are continuously running as long as the water is flowing, which it has in the last 90 years. That energy is available. But also, as I mentioned earlier, we have, as part of the Niagara facility, the Lewiston Pump Storage Facility, which basically takes water once it has flowed down the river into a reservoir. It's pumped up to a higher elevation, and we use that as energy storage. We're really storing the water, which is creating our energy. And our Blenheim-Gilboa facility, which is in the Catskills, which I mentioned is about 1,000 megawatt facility that also serves as energy storage for the Power Authority.
Francisco, I've read that flexibility is a key consideration regarding the impacts on equipment and the strategies that may be needed to pursue during modernization initiatives. Can you explain that, or maybe talk about that in a little more detail?
Yes, Bill, thank you. That's a really good segue, because although we're talking about long duration energy storage, that's also in some way being flexible, right? The ability to pump water up when you need to and actually let it flow down when you actually have that demand, right? That people that need the electricity. So, I mean, for me, pump storage hydropower is one of those sources of flexibility. However, if you put it aside and talk about, why is flexibility such a key topic so far, and I'm sure Alan would tell you from the owner operator perspective too, having these hydropower assets in a portfolio from an owner operator is very valuable. Flexibility comes about the ability from these plants to switch quickly to a change of a need from the electric grid to maintain reliability, and basically that everything is continuing to working as it is, as we all see it, right? What happens is hydropower as an energy generation technology has those capabilities to react quickly. And so if there is, let's say, that ramp up of solar when the sun comes out, and you may not need that amount of generation you have within that area that you're generating, you can actually task those hydropower units to then ramp down because you don't need that generation anymore. And so that's very key from the hydropower perspective. The challenge comes is that, as you can tell from the statistics of these hydro units, and specifically we're talking about, let's say in the United States, over 30% of these hydropower assets, which are about 80 gigawatts, over 2,000 plants within the US, are over 60 years old. Over 30%. The average age of these units is about 50 for the whole US fleet. Now, if you go back, let's say, more than 60 years ago or more than 50 years ago, those requirements for the grid were completely different. And so now what's happening is those designs or those components, those major components within hydro plants were designed with different conditions in mind. And so that reliability of hydropower now is being challenged by the changes that owner operators like Alan and the New York Power Authority are seeing. And so it is a key area of research within our program. And we've worked with our utilities to understand and more on a quantitatively way rather than a qualitative way, to really say, okay, we see qualitatively that this is in some way affecting or impacting our assets, but can we quantify how much quicker? What is that useful life decrease that we see within our assets? So it's a very interesting part. And actually, last thing I would say, Bill, about this area, because as I mentioned to you, don't get me going with hydropower, because I'll be talking for hours, and I know we have limited time here. One of the things to really understand is, although hydropower does not generate large amount of electricity per country or worldwide, if you look at with respect to the flexible generation, those percentages dramatically go up. So talking about worldwide, in 2020, hydropower only provided about 1/6 of the electricity generation. However, its flexibility was over 30%. And now we talk about those assets that are able to come up quickly, ramp up and ramp down. So that's why flexibility and hydropower are very a high topic so far.
Alan, as with NYPA being an owner operator of hydro assets, I mean, what are some of the specific challenges and opportunities you face as trying to, engage in continuing modernization tech efforts and stuff to extend the operational life of your facilities?
So a couple of things. First of all, we are involved in a multi-year, multi-billion-dollar effort called the LEM, which is Life Extension effort at not only our Niagara and St. Lawrence project, but also at Blenheim Gilboa. As I mentioned earlier, a plant built in 1956 is celebrating its 70th birthday, and we need to keep these plants operating, especially with the unique characteristics that hydro plants, don't take outages for refueling, so they're continuously running. So we're putting a lot of effort. The Power Authority has spent a number of $1 million putting together what's called our ISOC, which is our Integrated System Operating Center, which is located in our headquarters, which is taking a longer-term look at how the plant operates. So we put in, thousands of sensors, additional sensors, and those are reviewed in our corporate headquarters, allowing the plant operators to basically focus on the operation. So, for example, if there's metal filings in an oil system, that's lubricating, that's the job of these people in the ISOC, our staff in the ISOC, to monitor these to make sure the plants are really operating. But touching on what Francisco mentioned, the Niagara and St. Louis projects are really base load plants. As I said, they operate continuously as long as the water's coming. You turn them on, you walk away, and only fix them when really needed. And with the introduction of distributed energy resources, these two plants, the way we operate them has really changed because they're needed less when we have solar and wind and other distributed sources, and when those are not available, they are needed more. And as a result, the plants are cycled on and off. That cycling of the plant is not something that was originally designed 70 years ago when the plants were built. That has resulted in fatigue and sometimes on some of the metals, on crackings in the rotors and the blades. And so we are, in addition to repairing the equipment, we're really looking at the optimal way to operate these plants. All our options are on the table right now. It could include energy storage, battery energy storage, pairing that together with our hydro plants to take some of the load and the cycling off, and really doing analysis of how to operate the various turbines. Again, remember that there are a number of turbines at each one of the plants. Which ones do I turn on and which ones do I turn off based on what the demands of the grid are. So all that is in the mix, and all that is what our hydro engineers are looking at.
Alan and Francisco, thank you so much for joining us today. For our audience, if you'd like to learn more about what EPRI is doing in this area, please go visit www.epri, that's EPRI.com. If you'd like to learn more about what NYPA is doing, you can go to www.NYPA.gov for that. Gentlemen, thank you so much for this. Keep your calendars clear for a future booking. It will be happening at some point in time. That's it for this episode of EPRI Current. I want to thank you so much for joining us. I'm Bill Florence, and we'll talk to you soon. If you like today's show, we invite you to subscribe to our podcast. And feel free to share the podcast with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and Twitter at EPRI News. Together, we are shaping the future of energy.